Hello, welcome back. We are describing our distribution. We're using SOXY. S is for shape, O is for outlier, C is for center, S is for spread, and C is for context. Moving on to O today, O is outliers. And as you can see, we have our distribution of 17 numbers, so our N is 17. And we are working with the Cheetos example where you worked for Cheetos and you wanted to make sure that they were actually filling their bags with the amount of Cheetos that they said they were. And so you obtained a random sample of 17 bags and you're looking in each bag and counting those Cheetos. And in the first bag you found there's 15, the next one 13, 16 Cheetos, so on and so forth. So we want to see if there's any outliers. And if we just look at the data, we're going to find actually the 38 stands out the most because that's my ultimate goal would be to get a nice 38 bag of Cheetos. That'd be great. I love Cheetos. Maybe this 10, that would kind of be a bummer to get just 10 Cheetos. Or if maybe I got 10 and another teacher got 38, I'd be like, what? How'd you get all those Cheetos? Anyway, so we want to see maybe these might be potential outliers. We're not sure. So what we need to do is we need to run a one variable stats. Again, you have those papers, so you should pause this video and run a one variable stats. I need the quartile 1 and I need the quartile 3 to find outliers. So pause and come right back. Okay, I hope you're back. Here's our data set, and when you ran a one variable statistics, you should have got Q1 is 12.5 and Q3 equals 19. Now, we need to find what's called the interquartile ratio. And the meaning of interquartile ratio was explained in the spread video. So if you haven't gotten to see the video about spread, you should go and watch that video to find out the meaning of interquartile ratio. Interquartile ratio is also IQR, instead of having to write it out all the time. And that's going to be our our Q3 minus Q1. So we're going to take our Q3, which is 19, and subtract it from 12.5. Then take out our calculator and do 19 minus 12.5. And we're going to get 6.5. So our IQR is 6.5. Okay. Now our IQR and our quartiles help us to determine the boundaries for our outliers. So if we take our quartile 1 and we subtract 1.5 times that IQR, any number lower is an outlier. So we're going to have to go back and look at the data. So let's try this. So we're going to do 12.5 minus 1.5 times 6.5. You can hear me typing over here. 12.5 minus 1.5 times 6.5. And we're going to come out with 2.75. And any number lower than 2.75 from our data is an outlier. So let's go back up and see if we have any number lower than 2.75, and we do not have any number. So there are no outliers that are below. So no outliers. No outliers in data. And that's because there's no number below, no numbers below 2.75. Okay, now let's look at the other side, the Q3, and we're going to look above Q3. So we want to do Q3 plus 1.5 times our IQR, and anything above that number is an outlier. So let's calculate that. Oops, our Q3, I'm getting ahead of myself, is 19 plus 1.5 times our IQR. Getting it? Not. Let's try that one more time. 19 plus 1.5 times our IQR, which is 6.5. There we go. Let's see what that number is. 19 plus 1.5 times 6.5. We come out with 28.75. So any number above 28.75 is an outlier. So let's look. Go through and, oh, I'm going to hit that 38 as definite outlier. We got 25, but that's not above 28.75. So let's go back down here, and now 38 is above 28.75. So 38 is an outlier. And we just proved our first outlier. So we do not have any below our quartile 1 minus 1.5 times our IQR. But we do have one that's above, which is going to be our 38. So that lucky person who got that bag of 38, hope you enjoy it. And I hope this video helped. Thank you.